everything bigger in that direction. Double, basically. Okay, and that's going to give you, it is going to give you two similar triangles because they share that angle. And then the sides are, and then these are parallel, so that you get, yes, that angle compared to that angle. This is shared, so you're going to get AA. All right. So let's go through these. A prime, Y prime. See, how do we even know what A prime, Y prime is? Oh, there's A. Okay. Like, where are these? Where are these? All right, so there's Z prime, there's Y prime. All right, so AY prime perpendicular to AY. That doesn't seem, is that Y up there? I guess I'm sorry, I got all these. I should have done differently. Can't even see my own writing. Okay, let me do this differently so I can see it. Like that. Okay, so that's Y prime and that's Z prime. So AY prime, which would be, I don't know, I guess that would move as well. We don't know exactly where, but we'll just say somewhere here. Perpendicular to AY. Probably not. Looks like they'd be parallel. I mean, so I think what they're asking about here is that it's this one and then this new one. And it looks like they are parallel. They're definitely not perpendicular. Does AY prime or A prime Y prime, does that pass through the center of the dilation?
No,
I don't know. Yeah, AY prime intersects the point X prime. No, so I feel like that's the only even reasonable one there.
all right. 1 sec.
Really helps to draw it though.
All right. Let me do a screenshot of this. So this is the next one. For 3.
If triangle UVW is dilated from point U by a scale factor 2, which is true about A prime, B prime. Okay. Yeah, I mean, I think you've got it here. I mean, it does help to draw the rough doubling of it. Yeah, kind of not completely to scale, but AB, A, B prime, A prime looks like it's going to be double. Yeah.
Okay. Let me see what. So I just wanted to confirm that. Yeah. All right. 30. I'm gonna try this one, but it's number 4. It's in the chat right now.
Okay. Pretty good. So pool companies creating a blueprint for a family pool and a similar dog pool for a new client. Which statement explains how the company can determine whether pool LMNO is similar to pool PQRS? Okay. So we know that like the sides have to be in the right proportionality. PQ over LM. Okay, I see. So translate PQRS so that point Q lies on point M. That would be good. So we don't want, so we could have P lie on L. That would also be okay for the first one. But then the ratio, got to get the ratio right. LM to PQ, PQ to LM. Okay, so if we're going to dilate PQRS, it's got to get bigger. So is the ratio of PQ over LM, does that make it bigger or smaller? Just looking at it, like just you could pick numbers, like if that's 2 and that's 4, that's 1/2. So if you
Yeah, I
dilate
think it's,
PQRS, it's gonna get smaller. So I believe it looks like the first one would be the better choice. Let me know if I'm missing something. I know you already maybe submitted this
I didn't submit this yet.
or look at it as something else.
That seems to be right to me because only if like the bigger side on top, then only it can be like greater and bigger than its original. Yeah, this sounds correct. Because the other way around it'd be half and that'd make it smaller. Alright. This is one of the questions that we did get on. I haven't answered this question yet. It's one of the ones that
I
we
don't
did
remember
get.
looking at this yesterday with you or previous day. So if
Maybe I think we just went over the last. Oh yeah, right. I think we didn't go over
okay,
this
all right.
or the
Sorry,
next strong question.
you sent over a new picture. I didn't realize maybe you're referring to
Yeah,
that. Okay, here we
yeah,
go.
but I don't think we went over that. I think I did that by myself.
All right, if angle A is congruent to itself by the reflection property, which transformation used to prove that the triangles are similar? So you need another angle that's um congruent. So like again, like these angles are congruent. That's the big deal. You know, these up here are congruent. That's the big deal. So if you're dilating triangle ABC, it's got to get bigger. So translate triangle AD so that D lies on point B. No. Prove. Okay, so we have to prove that angles are congruent. So this side business is not important. Right? If you're doing angle, you don't care about the sides. Yeah, that's got to be a good test taken strategy you're starting to develop. So if you do translate the triangle, does B go with B or does B go with E?
D would go with B.
Yes.
All right, so this is another one. Also, we're gonna end up redoing number 9 and 10 too, because those are different questions.
Sure. All right, so you sent some over. Take a look. Let's Right, so again, I'm gonna redraw this, this smaller one here, just so it's oriented in the same way as the other one here. So the right angle is D, and then E is going straight up, and then F is over here. Okay. Maps angle F onto angle C. We just have that there, these angles right there. F is congruent to C, then which of the following statements is true? Well, we know that they already share an angle and they have another angle. F and C, so they have two angles again. So they are similar.
Got it.
But hang on. The hang on, that's not right because those triangles aren't right. A, B, C, A to B to C is not the same as F to D to E.
F to D. Oh, yeah, it says A, B,
That's
C.
that's a really
That
small thing there. Okay. Is BC similar to EF? BC, that is true. So the other one here, BC similar to EF because corresponding parts, similar triangles are proportional. That's not, I believe it's that's for congruence. The last one's for congruence. The third one's for similarity. A, B, C, F, D, E. Did you just maybe double check? Does your book have some language about the similarity transformations?
think so. Me too. Similarity. See, 3.2. I don't think it particularly talks about a certain like definition or something like that. Doesn't really certain way, but here, let me see what did that. Yeah, there doesn't seem to be anything like that in that lesson that it would be in the similarity lesson.
Yeah, I mean, I'm seeing similarity transformation as being okay. But the problem I have here is the triangle letters are wrong, so it can't be. It's
Yeah,
got,
because it's
you
talking
know,
about A, B, C, and then F, D, E.
yeah, it should be if it's A, B, C, then it should be D, E, F.
Yeah,
Now it's, yeah, I mean, it's not right, but it. So I guess if you're asking me, I mean, I would go with this one here. I would maybe double check the notes. I am seeing similarity transformations as being a common word.
got it. Yeah, nice call or song. Wait, let me just double check this next one. Yeah, this next one's the exact same. So let me put this in. Plus, yeah, you got it. Yeah, you got number 7 correct last time. So, all right, number 8. Let me see. Number 8's don't know. So let me put that in the chat. You probably should go. Number 8 is in the chat now.
Which triangle is similar to triangle PQR using the pieces of right triangle similarity theorem? PQR. There it is. Okay, so there's PQR. So we're looking for something else with a right angle in it. So our options are somewhat limited, but we did one like this yesterday. You see how, oops. You see how P, S, R, they both have angle P. We're not using AA, but that's okay. See how angle, the included angle is the same
Yeah,
in both, and they both have a right angle. That would normally be angle A or AA. That's normally the AA way to go about doing this. PQR, PRS. So RQS, we know that that is a right triangle. They don't share anything else. They share a side. So there is the hypotenuse leg, but we don't have that here. PSQ, they have a right angle, but nothing else shared. Although I guess you can say that this angle is congruent to this angle up here by alternate interior angles.
yeah, I guess that would work. Kind of,
That's
kind
that's
of
a little
saying
bit
that, like,
a
so
little
you're
bit of
saying
a
that,
stretch. Go ahead.
yeah. So basically, what we're trying to say is that PS, like that, not PQ, S, that line right there is the transversal sort of.
Yeah, exactly. This right here, the Z, as I call it here.
Got it.
So it does look like the focus is on this upper triangle. TSQ, the answer is QST. We just gotta get the order right. So PQR. So the middle one has to be the right angle. And that's not the case in any of these. All right. This is a triangle. Look
Yeah,
this one up.
TSQ and QST. Wouldn't they be the same exact angle? Or sorry, not angle. They're talking about the triangle. So Q. Yeah, one of them is the right. Wait, when I TSQ QST.
Yeah, I mean, what I'm seeing here is this RQS. The 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 right. I'm seeing that it's this. It's actually not this one up here. It's this other one that congruent. Plus, it actually matches up. RQS has the right lettering and go with PQR. Although it should be SQR. Unless they're congruent, then it wouldn't matter. All right, let me look this up find another example here.
Also another thing is that there is still some stuff that I would like to go over for the test.
Sure.
So if we could, I'm not sure if you'd be available still at 4 to like,
Yeah, we're still scheduled at 4.
all right,
That's no
yeah,
problem.
yeah,
I'm
perfect.
looking for an example similar to this one because I'm just not seeing it. Um,
So right to this question.
I keep seeing though that when you draw up an altitude, which is what this is, the other triangles are congruent. So I don't know why it would have anything
Well,
to do with this one on
here's,
the
let me
outside.
put this in the chat quickly. I think so. This is the question from first time, like this is, but the first, like, first time,
Is that right?
yeah,
Okay, E, A, D, E, M, E, C. Yeah, so then it is. If you go to your problem here, it's P, Q, R goes with R, Q, S. So it would be the first one. So,
got
so
it.
look at the mapping of your letters, the mapping of these letters.
Yeah, that kind of makes sense. RQS and yeah, no, and wait, so PQR. Yeah, that was sense. That makes sense. All right, next up is number 9. This is one of the written question.
Now, is this one that we did previously and you need feedback on, or that you got feedback on, or is it just a total redo?
We should do redo it because she didn't give any feedback on it. It was marked correctly the first time.
Okay,
The only ones that were marked incorrectly was 5, 6, and 10.
okay,
But since we're doing the retake, it has us redo it with like some of the new questions, and this one's one of the new questions.
yeah. So so part A, there are similar triangles. It's triangle, we'll go A, B, C. And then we'll choose we'll just choose this little one here. So it's triangle. On the right, we'll choose triangle, D, E, and then we get the letters right. B, A went to down the hypotenuse. No, sorry, it went down the long leg. B, A, C, looks like, okay. I mean, you could use either the one on the right or the left. It doesn't really matter, but I'm just choosing that one. So that's part A. Part B, we have to start by saying that angle C is congruent. Well, you got to use the right. We can't use one letter. Sorry, can't do that. So we have to say that angle BAC is congruent to angle ADC. Actually, before that, I'm sorry, before that, we have to say that we can't even say that yet. We have to say that segment AD is a perpendicular to segment BC. And that leads to angle ABC right angle is a right angle.
A, B, C.
Like we have to get that that's a right angle. We can't just jump to their congruent yet.
So angle 80 is progressing at BC. All right, then angle ABC is right angle. Angle there. Yep, I got that down.
So now we can say that the two angles are congruent because all right angles are congruent.
Got it.
All right, then, so that's one angle. We need two. So to get this second angle, you would say that angle ACB is
Right.
congruent to angle DCA. And that's the one where the angle is the same to itself. So there are common angles.
Wait, but wouldn't it be common wouldn't is it common is it the triangles because it's just oh wait, never mind. I was thinking of part A, never mind. So it's angle
Yeah, the angle, you have to say that the angle is the same in both. That's common.
is congruent because they're common angles. Congruent because they got it.
All right, so now we can say that the triangles are similar. So triangle ABC is similar to triangle DAC by a similarity postulate.
Triangles. EAC. EAC by similarity. Postulate. And 1 second, please. Try. All right, I got it.
All right, so that is it for part B. I mean, they're congruent. Nothing else to say.
All right, so for part C, it says that DB equals 9 and DC equals 4. Then find the length of segment DA.
Right.
DB equals 9.
Okay, so we got to go back to the original triangles here. If DB equals 9, so that's this one here, and DC equals 4. So this is that proportionality. We're looking at the small triangle and the medium triangle. And in the small triangle, it's the short leg is 4. Okay. The long leg, we don't know. We're going to call that X. This is part C. And then in the medium triangle, the short leg is X and the long leg is 9. So we know that X squared equals 36 or X equals 6.
Got it. All right, so, all right, so yes. Trying to find this. So then x equals 6, so then the side EA equals 6.
That's exactly right. DA is the X side. Yeah.
Got it. Yes. Yes. Alright, so number 10. This one's where the feedback was. Let me just put here, let me get the feedback again in here. So this was the feedback that we got for that. That was the feedback, let me put the problem.
Okay.
The
You want to
problems in
send
the
over the
yeah,
there it
the
is.
problems.
Is it the same or is it different? This
I think it's different here. Let me see. Number 10. Let me look at the new
yeah, I mean
retake.
it's different numbers. But
Yeah,
what the instructor's saying is look at the two triangles who share angle B. Okay, so I see the teacher wanted to use something different here. All right. Got it. Well, let me just see if these numbers are, I mean, I was telling you, it's like, man, these numbers aren't working out the way we want them to, and this doesn't. So here is what we should have been looking at. Here is B, C, G, say 425, 325, and 375. And then this triangle down here, we have to basically like rotate it. And so angle B is there. E though is up here. And P is over here on the left here. That reasonable?
yeah,
Can you see kind of that rotation?
yeah.
Now the thing that bothers me is how do we know that they're similar? They share an included angle. And you may also have an alternate interior angle. So I guess you're supposed to say that, for example, either like once you because this right here is parallel to this, or those lines are parallel,
Yeah.
this angle E is congruent to this angle G by alternate interior.
Because you can,
So that
because like the line GBE kind of acts like a
it's a
transversal there.
transversal. Yeah.
Got it. Yeah, I could see how that. She's looking for this.
Okay. So the
Yeah,
good news is that this is good to see. I mean, I don't know why the way we did the other day didn't. I mean, it seemed reasonable, but who knows? So BGC is similar to triangle BEP. That's part A.
geez, what the term BEP. Okay. BE. Explain how you know the triangles part A. There's
So we're gonna do basically the same thing we did in the last problem for part B. We're going to say that angle B, well, we're going to give the three letters for the angle. So for part B, we're going to say that angle CBG is congruent to, and I may have made a mistake here. Oh no, I did use congruence. Okay. CBG is congruent to angle PBE because they are common.
a common angle.
Yes.
That's P. Yeah. Wait, do we need to say that RPE is parallel to GC? So,
Not yet. We're just doing the one that's common.
oh, got it.
They're common angles, or, well, actually, they're not even common. That's not true. They're vertical angles. Oops. So they're vertical angles.
Got it. All right. I got that down.
So now, yes, now we do need to say that, we did this yesterday, since GR, get the right order here. Since GRPC is a parallelogram, yep, you can say that
Since gRPC is a parallelogram,
GR is parallel to PC or CP, and
para-
GE is a transversal.
wait, so G. Wait, so let me see right here. Since that parallel GR is parallel to CP, GR is parallel to CP, or should I just put segment GR is
Yeah,
parallel to
yeah, you can say that, or you can put the line over it. Segment's good as well.
segment GR is parallel to segment parallel to segment CP, and that is, and then GE is the transversal, or GE is a segment GE is a transversal. Also, when referring to a line, would you put like GBE or just the two endpoints
I would
GE?
just use the two endpoints with a little segment above it.
Got it. Because yeah, so we find out that the test is going to be online just like this almost.
Yep, make sure you
Yeah.
have all your snips,
Yeah.
you're welcome to ask me questions if you have them during our lesson later this afternoon.
All right. So I got that down.
So now, so because it's transversal, we can now say the angles are congruent. We can say that angle DGB is congruent to angle PEB
So
by
CGB
alternate interior angles.
is congruent to PEB through alternate interior angles. Got it. All right, I got that down.
All right, so now by AAA similarity postulate, you can say that the triangle BGC is similar to triangle BEP.
Is concurrent is similar to, or
Yes.
it would be it's going to be similar to triangle BGP. Wait 1 second. All right, there we go. All right, so I think that should be it for part B.
We are getting here to the end here, so let's make sure we get to part C here. Part C is not going to take very long, but
All right, yeah, I got that down. The last paragraph.
all right, so now part C is kind of where I was yesterday. It was a little bit like, wow, what do we do? So I'm gonna re-grab this and all right. Ooh, that's not what I wanted. Why didn't I grab? There we go. Okay. All right, so for part C, we have to first establish this relationship right there. So 225 K equals 325. So K is equal to 325 over 225.
Done.
But then we reduce that. I believe that's 9 over 4. Sorry, 13 over 9. Huh, that doesn't work out great. But okay, that's okay. So then we use the same thing to for the other one. So I believe we have to find sorry, just trying to get back to where, see which one I'm trying to find. Distance from B to E, so that's X. So 13 over 9 times X equals 425. So X equals 425 times 9 over 13. I don't know if that's going to work. Yeah, so that's not a nice number again. I wonder if I got these flipped. 17 over 9. Well, yeah, it's not working out very nicely, is it? This was the same problem yesterday. I would get, do you think you have any ability to communicate with your instructor between now and then?
I only have email now, so like,
Okay. Yeah, I
yeah,
was just gonna say, because these aren't working out nicely. Like when you take this 13 over 9 times that, and I tried the other variations on the numbers, it doesn't work out great either. So I'm a little unsure what to say, because I mean, you can do the same thing for Y. 13 over 9 times Y equals 375. Y equals 375 times 13 over 9. I mean, I mean, they give you numbers, it just doesn't give you great numbers. So maybe just have to go with it
yeah,
for now. Get these two. All right, well, we do have to stop here, Karthik, for right now. I hope this helped. I wouldn't worry too
yeah.
much, though. It's one part of one